Hi, everyone. This is your tutorial and lab description for the turning movement count data at an unsignalized intersection. And then how do we use that data to then model an unsignalized intersection in a simulation setting? Okay. So you're going to be doing some analysis, or at least looking into the turning movement count data. I'll explain how that data is collected. We're just going to use that data and then apply that in a computer software to build a model for an unsignalized intersection. So I'm going to go ahead and slideshow this. And I'm going to hide the meeting control panels. Okay. Okay. So first of all, what is simulation modeling? Because that's sort of the ultimate goal of this assignment, is to create a model for the real world transportation system. So basically simulation modeling, and the specific type of modeling that we are doing for this is microscopic simulation modeling, where we sort of represent movement of all the vehicles. And we're trying to represent that real world network on a computer. An example of this would be here. So if you click on this, you should be able to see that this is your Cal Poly campus. And one of my students in the past has created this model where we can represent movement of vehicles through the Cal Poly's network. And this network was created to ultimately estimate emissions for all Cal Poly morning peak hour traffic. How much emissions does that generate? And you could see that this is the unsignalized intersection on the campus. So this is a little bit north of the library here. So this is where the library is located. We are north of the library, and this is your Highland Drive, and it is an unsignalized intersection. Now we have come near the stadium here, and then there is this pedestrian crossing signal situation going on here. And you could see that this is sort of the traffic queue that develops over a certain time. And I'm just going to go ahead and fast forward this network, and you could see that. So this is the Highland Drive and California intersection. Even though I don't show the stop sign in a visual representation, those are there because you can see all the vehicles are stopping. So what type of data does just a model like this require? The type of data that we require is obviously what type of traffic control there is, stop sign and all of that. And then how much cars and traffic and pedestrians and bicyclists are passing by a certain location. So you'll need that information, where they're going. And then once we have all of that, we can input that in a software called PTV vSim, which is sort of the state of the art in microscopic modeling. Here you can see the Grand Avenue entrance to the campus. So I'm going to go ahead and stop this video right now. But I just wanted to quickly show you guys what we'll be doing in this lab is creating a very small versions, like a one intersection version of the same thing, where we can see the movement of vehicles. And once we have the movement of the vehicles, we can actually analyze that network for different types of scenarios. For example, we could look at what would happen if we convert that stop sign to a roundabout, or a stop sign to a signalized intersection. So we can then model a signalized intersection at the same location, see what type of delays we are observing, and we can get a lot of data out of that. Now, we are not actually going to do any kind of post-processing of the data. Our objective here is to just build a model where we can see the vehicles moving, and then we can do some real-world validation work and then analysis work later on. But if you're interested in all of that work, you'd have to take the CE 529 modeling and simulation in transportation engineering class that you could take as a senior elective. So, as I said, one of the most important data points in building that type of a model is traffic counts, traffic volumes. So traffic volume study, volume is the number of vehicles or persons or bicycles passing a point, entering an intersection, using a facility, a crosswalk, during a specified time period. So you could do the segments on roadways. And you can do this volume analysis on roadway segments, but then you can also do it at intersection approaches. What type of traffic is approaching the intersection from all sides? Volume kinds are samples of actual volume. Obviously, we're not going to monitor one location forever. We just try to kind of go in there at the most appropriate time periods or most relevant time periods. And then once we have those information, we could then use that data. So we're just basically sampling of the actual volume. We're not 24/7, 365 monitoring an individual location. We're just figuring out maybe 3 days over a year, or 5 days over a year. We observe that data, and then we just find like, okay, which one is the most representative sample of the actual volumes at this location. How do we actually collect this data? We can collect it manually. In some studies, this might be the best approach. For example, in certain locations, certain remote locations, you might not be able to, your technology might not survive very well due to weather situation, or the situation might be too remote, or it might be an environment where technology might not work very appropriately. If you want to collect some video-based data, maybe there's no good location to kind of place a video camera. Maybe it's not very safe or whatever. In some cases, manual count might be the best, although you're starting to see more and more sort of automated data collection systems come into play. There are some that are very highly technology-based, like data that are provided by streetlight vendor, like Streetlight, for example. And then, those types of vendor will provide you with data on street segments, and then maybe some origin destination count, where traffic is coming from, where it's going. And those are based on detectors and sensor. They're portable data collection counts that I'm going to show you in a minute. You might have seen that when we were talking about the spot speed studies as well. And then there are some video cameras based data. And then there are some cell phone based data as well. As I mentioned, the streetlight data that is coming out of the cell phone network as well. But there are issues with all different types of data. Some issue is like, the automated might not be super accurate, although that's getting better with the image recognition technology. But then there are, cell phone data might not be accurate because it might only represent the population that has cell phone. Now, you might think everybody has cell phone because all of your peers do, but that may or may not be true, especially if you account for folks who might be belonging to the lower social economic strata. So we have to be careful about the biases that might exist with the automated data. Sometimes, those could become pretty important. And that's why I say sometimes the manual count might be the best. So some of these automated things that you might have seen on the roadway while driving around or walking around. So this is sort of like a tube that is connected to a counter. And then this is sort of another automated system which can count your speeds and your traffic volume, how many cars are passing by. And then freeways, there are sensors as well. So some of the manual method, as I said, sometimes could be interesting and useful. In fact, the electronic count boards are actually the most common ways the traffic volume data are still collected. Tally sheets is basically, go in there with a pencil and paper, and on those sheets, you just do a tally marker. And in mechanical count boards, you have sort of some automation where you just kind of press a button and it mechanically adds another vehicle to the mix. And then you sort of have, for each movement of an intersection, you have a button corresponding to that they can press. So tally sheets are, look like this, where you could just put tally markers for each intersection approaches for through vehicles, whether it was a car or a truck. And then at the end of the data collection period, you just sort of, add it all up. So it's a pretty sort of rudimentary method. Mechanical is a little bit better, but you can see you can press a button for the through, left and right. And then you could separate out the trucks as well. So there might be ways of doing that. And then this is the electronic board. So this is sort of the most common one to fill out. We have one in our Institute of Transportation Engineering lab. So if you ever are interested, you could check that out. I'll be happy to show it to you. Just reach out to me. But these are, and again, you press the buttons and it kind of does the count for you. And then you can download the count and the spreadsheet associated with that on a computer. So that's a pretty more efficient, much more efficient method, and also pretty common these days. Now, when you go out to collect the data, what time should you collect the data? What days of week? So we typically try to collect the data during middays. But then if there are locations where the weekend volumes might be significant, we also might want to collect the weekend data. And what I'm going to show you at the end of this, or a little bit further into this presentation, is what does the traffic volume data actually look like, right? So we typically try to do, definitely want to collect the midday data on most streets, because that's where we sort of Tuesday, Wednesday, Thursdays of the week. We want to collect the data whole day to figure out what time is the morning peak hour, what time is the afternoon peak hour. But again, due to the pandemic, these peaks have been flattening, and then the midday traffic has been going up because there has been some work from home. But again, we'll see how this pattern will stabilize into future years. So still we want to collect the data over the whole day, because we've seen after the pandemic, because people are working maybe 2 or 3 days a week from office, but then the rest of the days they're working from home. But then when they work from home, they go out for lunch. So maybe the overall traffic count hasn't gone down, but it's just been a little bit flattened out, which is sort of an interesting thing. But we're still figuring out exactly what's going to happen to our traffic issues as we move forward. So peak hour volume. So that's an important concept in turning movement count. It's the maximum number of vehicles that goes through a particular point on a roadway for 60 consecutive minutes. So this is like, if you measure the time, this is what it looks like. Each roadway location has a certain capacity. And then what happens is that the capacity typically is exceeded by a little bit in the morning, and then midday might remain the same, and then the afternoon might exceed that by a little bit more. And again, as I was saying, this chart was created before the pandemic. So what we are seeing now is that a little bit more flattening of these peaks, but then a little bit more increase in the midday period. So you don't actually, you see these numbers rise up a little bit, these come down a little bit. But again, the exact patterns depends on what's happening in those specific locations. But the idea is still the same, is that, anytime you have demand exceeding capacity, you will see congestion. And we are very interested in what does that peak hour traffic count looks like, right? So we are always interested in that. So once you've done with your data collection for an intersection, this is what the data would look like. You will have approach volume. That will be for each approach, 1601, for example, that's the total of the through volume, 1252, left turning volume, 182, and 167, that's the right turning volume. And same thing here as well. So you'll always see 3 numbers associated with that. And then there will be a percentage of truck volume as well. So you could see that the southbound approach has the most percentage of truck, 4.22%. But then you see the total number, 1024 vehicles per hour. The 735 are going through, 141 are going left, and then 141 are going right, and 148 is going left. And for each approach, you have these 3 numbers. And how do we determine the total intersection approach volume? We just add up all the approach volumes, all the vehicles that are entering total. So this 1024 is the sum of these 3 numbers. This 1601 is sum of these 3 numbers. This 1124 is the sum of these 3 numbers. And this 1897 is the sum of these 3 numbers. And we add this, and these 4 numbers, and we get our total intersection entering volume. And then this is again another one of these road existing volume. You could see, so you could estimate. So this is for a signalized intersection, and I'm showing some phasing diagram. We're not going to worry about that, because in this lab our focus is just to model the unsignalized intersections. But if you take the classes in CE 421 traffic engineering, and then also the class on modeling and simulation, CE 529, you will encounter how to actually model these signals as well. But for now, I'm just showing you that this is what the data might look like. And again, if you're interested, you could figure out approach volume from all 4 approaches. You could add those up to figure out the individual approach volumes. And then if you sum all 4 of those up, you'll get the total intersection entering volume as well. So this is what the data looks like. So for example, here what I'm trying to show you is that how do you figure out the peak hour on an intersection location, right? So this is showing you data all the way from starting from 6 a.m. and the data are collected every 15 minutes. There is count, 0 U-turn, 47 left turn, 72 through turn on Fillmore Street eastbound. There is no right turn here. Maybe that's not even allowed because I see zeros all through. So maybe there is no right turn here. But that's okay. You know, that could possibly be the case. Not every intersection has to have a right turn because that movement might itself be blocked. And then same thing for Fillmore Street westbound. You have the same thing. U-turn left, through and right. So there is no left turn here, okay, because it might be the off ramp here. So that's why it might not be there. And then same thing for the northbound off ramp. No U-turns, left turn volume, 0 through volume because it's an off ramp and everybody either just turns right or left. So you got these numbers, and then for the on ramp, basically there's no traffic that goes through that intersection. It's basically just a three-way approach. So you can see that. So if you add all these numbers up, you get a total entering volume for the intersection approach every 15 minutes. Because remember, this data is every 15 minutes. So 6 to 6:15 is here, 6:15 to 6:30 is here. And then you could start adding up the total number of volume. So if you want to find out how many vehicles enter this intersection between 6 and 7 p.m., you can add up these four numbers. You can add up the numbers. If you add up these four numbers, you'll get 2043. So this is the total entering volume at that intersection. Between 6 a.m. to 7 a.m. Now, if you want to find out what was the traffic volume that entered this intersection between 6:45 to 7:45, right? So if you want to figure that out, 6:45 to 7:45, you'll add up these four numbers. So what do these four numbers add up to? They add up to 3325. Okay. So now I did that rolling hour. So the rolling hour is calculated as I get 2043 by adding up these numbers. And then the next step becomes when I get the next number, I drop off this first 15 minutes and I get the next one. So you could see that if I add up these numbers, I get 2,463. And if I keep doing that all across, and these numbers represent 8 to 9, and here I'm highlighting this number. Okay, no, sorry. Here I'm highlighting these four cells, these four rows, right? They are highlighted in the original image. What do they represent? If you look at those figures, that number corresponds to 3,661. You will see that this number is in fact highest among all these rolling hour numbers. Okay, so that tells me that the hour that started at 7:15 and ended at 8:15 is my peak hour, because that gave me the highest possible 1 hour number. Okay, so my 7:15 to 8:15 hour is my peak hour. Okay, now we are sometimes also interested in what is the peak 15-minute traffic flow. Okay, the peak 15-minute traffic flow here is highest of these four numbers, highest of the peak for these four numbers. Okay, highest of these four numbers right here. Okay, what is the highest of these four numbers? You can see it's 987 compared to these four numbers. So that means this hour from 7:45 to 8 represent my peak 15-minute traffic volume. And I can actually then use that to determine the peak hour factor. And I'm not going to get into all that right now because you learned that stuff in the CE 321 class and how to determine peak hour factor. But what I wanted to show you is that we are interested in what is the peak hour, where the maximum traffic over the 1 hour occurs. And within that peak hour, I'm interested in what is the peak 15-minute traffic volume. Here it's 987. Okay, so for now, we're just going to learn this. But then in CE 321, our introductory lecture class on transportation engineering, we learn how to convert these numbers into what we call a peak hour factor and all of that. So you'll learn that stuff a little bit later. But for now, it is suffice if you can find the peak hour and the peak 15-minute volume numbers. Okay. I'm going to move on and clear all drawings from here. So what we want to do next is that we want to look at the data from City of San Luis Obispo. And once we have the data from City of San Luis Obispo, we are going to use that data to model an unsignalized intersection of your choosing for this lab. Okay. So for example, first thing that you need to do here is to download a software called PTV Visim. And PTV Visim is, you're going to be downloading a trial student version. So it's a very fairly limited version of what the full software suite can do. But for our purposes, that would be sufficient. So I'm going to go ahead and click on this link here and show you what that looks like. And if you click on that, this is where you'll get to. And if you click on this, I'll go ahead and annotate my mouse here. So if you click on this download PTV Vision and VisWalk, you click on this, and then it starts to download a software, and you double click on it and you accept their terms and conditions and all that, and you will be able to install the software on your computer. Okay? You'll be able to install the software on your computer. So this is the first step that you need to do, is install the PTV Visim, because that's where you're going to be using the traffic volumes and everything else to create that intersection. Okay. The next step will be to actually go out and select an intersection from the City of San Luis Obispo. And to do that, you will do this. You'll click on this link here. You'll click on this link, and that'll take you here to the City of San Luis Obispo website. And remember, what we need to do is find an unsignalized intersection, not a signalized intersection. We're not modeling that. We're modeling an unsignalized intersection that doesn't have traffic signal. Okay, so how do I know where traffic doesn't have traffic signal? So maybe it's near your house where you live, so you can go ahead and select that, or you can click on these intersections and you could figure out what type of control exists. So for example, this is an intersection of Marsh Street and Choro Street, but this says traffic signal right here. So this is not the type of intersection that I want. Okay, so I'm going to go ahead and try to close this out and try to find an intersection that doesn't have traffic signal. Okay. So for example, I'll come maybe right here. But there's no traffic count data here. So I need to have the traffic count data at that intersection too. So I'm looking for both. I'm looking for where I have the traffic counts, but then I also have the unsignalized intersections. So I look at that. Oh, look at this, Grand and Mill. It has type of control two-way stop, which is not a signal. So this intersection works for me. So you could click on this and more info, and this will take you to all the data around that intersection. And then this is the data, and this might be old data, and that's fine. You'll just use that data, whatever data is available on the City of San Luis Obispo website. So you're going to just use that. And we are mostly interested in just the vehicular volume. Okay, so you could look at that data, and you could see something similar that I showed you on the slide, but it should give you. And this is how they represent the pedestrian data, pedestrian crossing data and all that. So you could see that, how many pedestrians go which way, how many pedestrians actually cross the street and all of that. But for now, we're just kind of interested in the vehicular volume. And then this is where I want you to model the afternoon peak hour. Okay, so I want you to model the PM peak hour. So you'll be interested in this volume. Okay. So you could see that for the PM peak hour, you're not going to model the midday. You're not going to model the AM peak hour. You're just going to model the PM peak hour. And then you can see the PM peak hour actually is the highest. And that's typically the case. So for this approach, for Grand Avenue, this approach is 664 traffic volume. That's the total. 56 are going right, 25 are going left, 583 are going through. And then again, for this approach also, you're going to pick up the PM peak hour. So you're always going to look at the PM peak hour. So always look at those data points only. This is the PM peak hour. So you just kind of look at that data. So this gives you the hourly volume for the PM peak total that you're going to use to model. So you're going to use 664. You're going to use 144. Oh, I'm sorry. No, you're going to use 664. You're going to use 48. Okay, that's your PM peak time data. You're going to use 370 for this approach, and you're going to use 17 for this approach. Okay, so just make sure that you're not looking at total, you're not looking at MD, you're not looking at AM, you're looking at the total volume, and then you'll sort of model them, how, the turning movement count data. So you're going to model them in vSim. Okay, and again, what you'll do is once you've selected the location here, you're going to go into this sheet. This sheet has your name, and I want you to fill out the information on this spreadsheet of where you're modeling that intersection. I'm just going to pick, pick on Cody here, and I'm going to put the name of the student, and you'll have your names on here, and then right next to your name, you will just put in the information of where you're modeling the data. So I'm modeling, I saw that Grand and Mill, right? So I'll just click on Grand and Mill. Okay, I'll just enter that information, and you need to make sure that you're not using a location that somebody has already picked out. Okay, so just pick a location, a four-legged location, but not signalized. So it could have two-way stop, it could have four-way stop, but it cannot have a traffic signal. Okay, so just pick a location that's unsignalized control, and just make sure that you go onto the sheet here, add selected location to the spreadsheet here, and once you've done that, you're ready for the next step on your assignment. So we're going to go to the next slide here. So you'll download the traffic volume data, you'll find the PM traffic volume, just the automobile volumes are sufficient at this point. And then I've provided you with a step-by-step tutorial on how to use vSim. So you're going to, once you've downloaded and installed the software, you're going to follow the steps on this Google Doc, and then you're going to follow the steps there. And I can open this up as well for you. Okay, so you're going to open vSim. You're going to forget the name of the file. You could call it whatever, lab 9 or whatever you're going to call it. That's fine. But you're going to basically follow the steps here to create that model for an unsignalized intersection. So that'll be the next step. And then once you have that step, once you're done with all the steps on that tutorial, and that tutorial is somewhat involved, it's like 6 pages worth of steps that you need to follow. And then once you have that step, you will see at the end of it, you will be able to run that model. You'll see traffic vehicles moving and all of that. And again, as I mentioned before, we are not going to actually analyze any data or do any tinkering with that data on creating a two-way stop into a roundabout or anything like that. Our purpose is just to get our first touch and feel of a simulation model. And then you're going to upload the vSim model, which is going to be a file with an extension INPX that I want you to upload on your submission in Canvas. So you're going to submit that file, and that's all there is to it. I know it's pretty involved here. So watch this video. Once you watch this video, make sure you follow the steps of the tutorial. And any step of the way, if you run into any confusion, feel free to reach out to me, and I'll be happy to answer any questions you might have. Okay, thank you so much. I'll see you later.